Dr. Kalpana Upadhyay, Assistant Professor, Pandit Deendayal Upadhyay, Adarsh Mahavidyalaya, Dalgaon. My talk shall be on influence of substituents on liquid crystalline behavior of biphenyl-based 4-ring Bencourt compounds. Introducing liquid crystals, it's a state of matter having properties between conventional liquid and solid. It has the fluidity like liquid and rigidity like solid. There are various types of liquid crystals: thermotropic, lyotropic. Thermotropic is further classified into calamatic, discotic, and band shape. Now, in the calamatic shape, calamatic liquid crystals are those which are rod-like in shape. Discotic are disc-like. Band-shaped, they are basically two types. One is banana-shaped and the other one is hockey-shaped. Now, my work is based on hockey-shaped molecules. The focus on shape is because rod-shaped molecules, they tend to stack one on top of the other, as a result of which lower ordered phases like pneumatic phases are observed. But in band-shaped molecules, lower ordered pneumatic phases are rarely observed because the kink in the molecule tends to arrange the molecules one on top of the other in an orderly arrangement, due to which only highly ordered phases like spectic phases are basically observed. Another one, my work is basically based on biphenyl-based Bencourt molecules, because the first molecule that was used in display devices was the biphenyl rod-like compound, biphenyl-based rod-like compound, and these biphenyl molecules are basically they have potentially applications in electro-optical devices. They are photochemically stable. They are stable towards oxidation, and crystal to pneumatic to isotropic phase transitions are very close to room temperature, which is a very important factor for any molecule to be used in display devices. This is a synthetic procedure of the compounds synthesized. I used 4-dihydroxybenzaldehyde and I alkylated it. After that, I took a nitro derivative and I reduced it using palladium charcoal to amine compound. The alkylated hydroxyaldehyde and the amine derivative were further condensed to produce Schiff spaces. This was further made to react with hydroxy substituted cyanobiphenyl compound and to further produce an ester linkage. In this similar procedure, I have prepared a series of compounds. Cyanobiphenyl-based 4-ring Bencourt compounds, fluorobiphenyl-based 4-ring compounds, and chlorobiphenyl-based 4-ring compounds. Also, I tried to make efforts to use different lateral substituents at the central core to study the structure property relationship. After the compounds were prepared, the liquid crystalline behavior were ascertained by two complementary studies. One is polarizing optical microscopy and the other one is differential scanning calorimetry. The polarizing optical microscopy showed that the lower homologue of all the series showed pneumatic phases, which are low ordered phases, and the higher homologue showed high ordered phases, which is a smectic phase, and these textures were further complemented by DSA studies as well. Out of all the series, I could see that the fluorobiphenyl derivatives showed polar phases, which was ascertained by using electric field effects. When I used electric field on the C12 homologue of fluorobiphenyl derivative, I could find out that the textures changed on changing the electric field, which is called as a switching behavior, and this is a very important parameter required for any compound to be used in display devices. I also could observe that substitution by fluorine decreased the melting point of the compounds, which is again very much required for any compound to be used in LCD devices. Also, increased chain length suppressed the pneumatic phases. And one of the most important studies which I found from my research is that the lateral polar groups on the central group tends to suppress mesomorphism. So these were some of the important observations from the studies done. Thank you for hearing to my lectures. Thank you so much.